National Electrical Code Section 430.223 does permit the use of Liquidtight Flexible Metal Conduit, or LFMC, for connecting to motors operating at over 600 volts. However, the code also requires that the product be listed for the specific application. It is critical to understand what listed means in the context of electrical installations. Being listed means that a product has been evaluated by a nationally recognized testing laboratory, like Underwriters Laboratories or Intertek, and found to comply with specific safety standards. This evaluation includes testing the product under various conditions to ensure it performs safely and reliably within its intended voltage and current ratings. The listing is typically indicated by a mark on the product, such as the UL or ETL logo. This mark signifies that the product has met the requirements of the relevant standards and that the manufacturer participates in a program of periodic follow-up inspections to verify continued compliance. When the code requires a product to be listed, it is not merely a suggestion, it is a mandatory requirement. This requirement is in place to ensure that electrical installations are safe and that the products used are suitable for their intended purpose. Using non-listed products, even if they appear similar to listed products, can create a significant safety hazard. These hazards can include electrical shock, fire, and equipment failure. Therefore, always verify that the electrical products used in an installation are listed by a recognized testing laboratory. Since there is no listing for LFMC above 600 volts, it cannot be used for the application that was described. National Electrical Code Section 430.22 requires that Liquidtight Flexible Metal Conduit be used only in accordance with this listing. This is a fundamental principle that applies to all electrical products. Electrical products must be installed and used according to the manufacturer's instructions and the conditions specified in their listing. Using a product outside of its listed parameters can create a safety hazard. For example, if LFMC is not listed for use above 600 volts, using it in a higher voltage application could lead to insulation breakdown, arcing, and potential fire. It is important to adhere strictly to the listing requirements to ensure the safety and reliability of electrical installations. Again, since there is no listing for Liquidtight Flexible Metal Conduit above 600 volts, it cannot be used for a 5 kV motor connection. National Electrical Code Section 430.227 permits the use of flexible metal conduit in sizes larger than trade size 4 when terminating at motors of more than 50 horsepower. However, it does not waive the requirement for the product to be listed for the application. The exception for larger sizes does not supersede the need for the conduit to be rated and listed for the voltage at which it will be used. The listing requirement remains paramount, regardless of the conduit size. Understanding the National Electrical Code, or NEC, is essential for ensuring electrical safety. The NEC is a comprehensive set of standards and guidelines that govern the installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and best practices. The purpose of the NEC is to protect people and property from electrical hazards. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is not a law itself, but it is often adopted by state and local jurisdictions as part of their built-in codes. Compliance with the NEC is typically required for all electrical installations. The NEC is organized into chapters, articles, and sections. Each section addresses a specific aspect of electrical installations. For example, Article 430 covers motors, motor circuits, and controllers. It provides detailed requirements for the installation of motors, including conductor sizing, overcurrent protection, and control circuit wiring. To effectively use the NEC, it is important to understand its structure and how to navigate its various sections. The NEC also includes tables and examples that can be helpful in applying its requirements. For example, tables can be used to determine the ampacity of conductors based on their size and insulation type. Examples can illustrate how to apply the code requirements in specific situations. Staying up to date with the latest edition of the NEC is crucial for electrical professionals. Changes to the code can impact the way electrical installations are designed and installed. It is also important to participate in continuing education and training to stay informed about the latest developments in electrical safety. When working in hazardous locations, additional precautions are necessary to prevent explosions and fires. Hazardous locations are classified based on the type of flammable or combustible materials present and the likelihood of those materials being present in ignitable concentrations. Class 1 locations are those where flammable gases or vapors may be present in the air in sufficient quantities to produce explosive or ignitable mixtures. These locations are further divided into divisions based on the frequency and duration of the presence of flammable materials. Division 1 locations are those where flammable materials are present continuously, intermittently, or periodically under normal operating conditions. Division 2 locations are those where flammable materials are present only under abnormal conditions, such as the spill or equipment failure. Class 2 locations are those where combustible dust is present. Class 3 locations are those where easily ignitable fibers or flames are present. In Class 1, Division 2 locations, electrical equipment must be designed and installed to prevent ignition of flammable gases or vapors. This can be achieved through various methods, such as using explosion-proof enclosures, intrinsically safe circuits, or non-incendied equipment. Explosion-proof enclosures are designed to contain any explosion that may occur within the enclosure and prevent it from propagating to the surrounding atmosphere. Intrinsically safe circuits are designed to limit the amount of energy available to a level that is too low to ignite flammable materials. Non-incendive equipment is designed to prevent arcs, sparks, or hot surfaces that could ignite flammable materials. When selecting electrical equipment for hazardous locations, it is essential to verify that it is listed and labeled for the specific class and division of the location. The equipment must also be installed in accordance with the manufacturer's instructions and the applicable codes and standards. Regular inspections and maintenance are necessary to ensure that electrical equipment in hazardous locations continues to operate safely. This includes checking for damage, corrosion, and loose connections. Any equipment that is found to be defective should be repaired or replaced immediately. The recommendation would be to use a cable assembly rated for 5 kilovolts that is listed for the application. This ensures that the cable assembly is designed and tested for use at the specified voltage and that it meets all applicable safety standards. Using a cable assembly that is not rated for the application could lead to insulation breakdown, arcing, and potential fire. When selecting a cable assembly, it is important to consider the environmental conditions in which it will be used. For example, if the cable assembly will be exposed to moisture or chemicals, it should be rated for those conditions. It is also important to consider the temperature range in which the cable assembly will be used. The cable assembly should be rated for the minimum and maximum temperatures that it will be exposed to. The installation of the cable assembly should be performed by qualified personnel in accordance with the manufacturer's instructions and the applicable codes and standards. The cable assembly should be properly supported and protected from physical damage. The connection should be made using approved connectors and terminals. After the cable assembly has been installed, it should be tested to verify that it is functioning properly. This includes testing the insulation resistance and the continuity of the conductors. Regular inspections and maintenance are necessary to ensure that the cable assembly continues to operate safely. This includes checking for damage, corrosion, and loose connections. Any cable assembly that is found to be defective should be repaired or replaced immediately. Understanding the various types of cable available is crucial. Firstly, there's non-metallic sheathed cable, often called NM cable or Romex. This is commonly used for residential wiring. It consists of 2 or more insulated conductors enclosed in a non-metallic sheath. NM cable is suitable for dry locations only and cannot be used in damp or wet locations. Secondly, underground feeder cable, UF cable, is designed for direct burial in the ground. It has a moisture-resistant jacket and is suitable for use in wet locations. UF cable is often used for wiring outdoor lighting, pumps, and other equipment. Thirdly, metallic sheath cable, MC cable, consists of insulated conductors enclosed in a flexible metallic sheath. LFMC cable is suitable for use in both dry and damp locations. It provides better protection against physical damage than NM cable. Fourthly, armored cable, AC cable, is similar to NC cable but has a different type of metallic sheath. AC cable is also suitable for use in both dry and damp locations. Both MC and AC cables are often used in commercial and industrial buildings. Fifthly, tray cable, TC cable, is designed for use in cable trays. It is typically multi-conductor cable with a flame retardant jacket. TC cable is commonly used in industrial applications. Sixthly, medium voltage cable is used for power distribution at voltages above 600 volts. It has a high voltage insulation and is typically shielded to prevent electromagnetic interference. Medium voltage cable is used in power plants, substations, and large industrial facilities. Seventhly, high voltage cable is used for power transmission at very high voltages. It has a very thick insulation and is often installed underground or overhead on transmission towers. High voltage cable is used to transmit electricity over long distances. When selecting a cable, it is important to consider the voltage rating, ampacity, and environmental conditions. The cable must be rated for the voltage and current that it will be carrying. It must also be suitable for the environment in which it will be installed. For example, if the cable will be exposed to moisture, it must be rated for wet locations. It is always best to consult with a qualified electrical professional when selecting and installing electrical cables. They can help you choose the right cable for your application and ensure that it is installed safely and in accordance with the applicable codes and standards. The importance of proper grounding cannot be overstated. Grounding provides a low impedance path for fault current to flow back to the source. This helps to quickly trip the overcurrent protection device such as a circuit breaker or fuse and to energize the circuit. Without proper grounding, a fault current could flow through a person or object, causing electrical shock or fire. There are two main types of grounding system. Firstly, equipment grounding, which connects the non-current carrying metal parts of electrical equipment to the grounding system. This includes the metal enclosures of appliances, motors, and other equipment. Secondly, system grounding, which connects the neutral conductor of the electrical system to the grounding system. This helps to stabilize the voltage and provide a reference point for the system. Grounding electrodes are used to connect the grounding system to the earth. Common types of grounding electrodes include ground rods, ground plates, and metal water pipes. The grounding electrode must be properly sized and installed to provide a low impedance connection to the earth. Grounding conductors are used to connect the equipment and system grounding to the grounding electrode. Grounding conductors must be sized according to the requirements of the National Electrical Code. Bonding is the process of connecting different metal parts of the electrical system together to create a continuous electrical path. Bonding helps to reduce the voltage difference between different metal parts, which can prevent electrical shock. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power line switching, and other events. SPD divert the surge current to ground, preventing it from damaging the equipment. Regular inspections and testing are necessary to ensure that the grounding system is functioning properly. This includes checking the connections, conductors, and grounding electrodes. Any problems that are found should be corrected immediately. Proper grounding is essential for electrical safety. It protects people and property from electrical shock and fire. It is important to understand the requirements for grounding and to ensure that the electrical system is properly grounded. Always consult with a qualified electrical professional when designing and installing a grounding system.